So, as we're checking out this is 5-6 in your textbook. Now, this sheet doesn't necessarily go along with that exactly from the chapter, but it's a good way for you guys to be introduced to how to graph linear inequalities. So, remind your neighbor what you know about inequalities. Okay? Go for it there. What do you know? Hey, go ahead and wrap up discussion. I want you to take and open your workbooks to 159. Have this sheet off to the side there. 159 of your student journals there. It's sad that you weren't in school this weekend. It's sad. Sad you couldn't do math this weekend.
Very sad.
It's sad as well. Sad me? You did some math. I saw it. All right. So, hey, you guys are on page 159. All right. Good place for you to take some notes here. Linear inequalities in two variables. In your own words, describe the meaning, the solution of linear inequalities, graph of linear inequality, and then half planes. Okay, we'll kind of go through those, and then underneath there, it kind of gives you the ways to solve these. But just as we're talking about this, it may be helpful for you to make a few notes. First, you graph this, hopefully on your paper. This is a linear inequality with two variables. Obviously, it has two variables, and it's an inequality because this is not an equal sign. Right? You have the less than or equal to sign. Okay, we've graphed our line. A couple of things you need to recall about inequalities. First, when you're solving them, you get regions. So when you're actually coming up with a solution, you're coming up with a shaded region. Now, earlier this year, we graphed things on a number line. So if we had, say, x is greater than 2, we plotted it. Anyone remember what we put right here?
Just a circle.
Yeah, we just had an open circle, right? When did we have a closed circle?
When it was.
Caden?
When there was a line when you used it.
Good. When there's a line under it, and that means we're equal to. Okay. So right here, it's open. If it were this, then we'd have a closed circle. So that was kind of our introduction to this. This meant that 2 could be a solution. This one means 2 cannot be a solution. Okay, they both say that anything bigger than 2 would satisfy this. Like if I put, I don't know, Jake, give me a number bigger than 2.
7.
Okay, if I put 7 in there, 7 is greater than 2, so that's a solution. It makes it true. 7 is greater than or equal to 2. That makes it true. Okay, so we're doing the same thing here, but this was solving systems this linear inequalities with one variable. Now we're dealing with linear inequalities with two variables. So if we have two variables, that means we're in an xy axis, a coordinate plane. So we graph it like we do normal lines. That's why I had you go through and just complete this page putting in the lines. Okay, so we have this line in here. Now we have to figure out which half plane to shade. Now the word half plane in here, as you're going through this, linear inequality in two variables, maybe you can give yourself an example there. But down here at the bottom it says half planes. A half plane is is either side of this line. Which side of this line do we want to shade? Okay, so in other words, where do my solutions to this lie? Do they lie up here? Paying attention here, don't zone out right now. I know it's early to do the math. Do they lie up here or do they lie down here? So how could we figure that out? Don't know. Talk with your neighbor. How are you going to figure out where all your answers are that work in this equation? Are they up in here or are they down in here? And talk with your neighbor about it. All right. How are we going to do it? I had my drink of coffee, so I'm ready now. How are we going to do it? No ideas? Dude, someone give me a point up here. Like a coordinate from this area, this half plane. Yeah?
1 and 3.
1 and 3. All right, let's find 1 and 3 right there. So that point right there. What could I do with that point to see if it's a solution to this? Cool? Yeah, let's plug it in. So I have y is less than or equal to 2/3 x minus 1. And so if I plug it in, 1 and 3, so x is 1, y is 3. So we put it in here. Now that gives me 2 times 1 divided by 3, or 2/3, minus 1. So 3 is less than or equal to 2/3 minus 1. Well, 2/3 minus 1, I know that's 3/3. 1 is 3/3. Okay, because 3 divided by 3 is 1. So 2/3 minus 3/3 is negative 1/3. Is that true? Is 3 less than negative 1/3? No, that's not true. Which means this cannot be an answer. Which means, can I shade above here? No, because I'd be shading over that, and we know that's not an answer. That's not a solution. That means my solutions lie down here. So we shade everything on this side. That means any point on this side would be a solution. Okay, so if I were to test another point, like one on this side, and I'm going to pick an easier point. I'm going to use one with a 0 in it. So maybe like 0 for x and 2 for y. So this point right here. So if I said y is less than or equal to 2/3 x minus 1, and I put 0 for x, look how nice that is when I multiply that by 0. Negative 2 for y, that gets that out of there. So I get negative 1. I get negative 2 is less than or equal to negative 1. Is that true? Negative 2 less than negative 1? Yeah. So this is true. That's why we had a shade over. Okay. What would have been an easier point up here to test? I mean, we could test any point. Ryan gave us this one. This is a good one. But what's the easiest point on this side?
1, 1.
1, 1's pretty easy. One easier?
0, 0.
Yeah, 0, 0. Zero's our hero, dude. Tell your neighbor why 0, 0 is so easy to use. Hey, Chelsea, why is 0, 0 so easy to use? Yeah, when you multiply nothing, you get 0. That's easy, man. At least make x 0, right? Because that gets rid of this piece. All right. Very good. Any questions on that? All right. I want you to go ahead and figure out where you're shading for number 2. Work with your groupie there. You guys should have it graphed. All right. Hey, I am going to test 0, 0 again. Okay, I like that point. So 0, you could test any point, but 0, 0 seems to be the easiest. That part's gone. Is 0 greater than or equal to 2? The answer is no. This is false. Okay, which means, can I shade this point? No, I've got to shade up here. How many shaded correctly? Okay, good. Any questions on it? And some of you didn't raise your hand. I'm not sure if you got it or if you're just tired and that's a lot of work to put your hand up. So everyone rate themselves 1 to 5 right now on what we've talked about today. Okay. Well, really, there's one last piece here. So any questions before I move on to this last piece? Take a look at my line on number 3. How does my line differ on 3 than on 4, other than the slope of it? Cool? Yeah, I've used a dashed line here. You remember what we talked about at the beginning where we had open circles and closed circles? Remember if we had this symbol, we had a closed circle, meaning 2 is a solution. If I put 2 in here, 2 is greater than 2, or it's equal to. Greater than or equal to, so that's a solution. Here, if I put 2 in, 2 is not greater than 2. So that's not true, so that isn't a solution. Well, on this one right here, on number 2, if I were to pick a point on this line, good morning, you just said it right there, thank you. Okay, if I were to pick a point that's actually on this solid line, like the ordered pair 0, 2, and I were to put 0, 2 in here, so 2 for y and 0 for x, if I put that in, that part disappears, but I get 2 is greater than or equal to 2. Is that a true statement? Yeah, it's equal to 2. So the point on this line works. Okay? When you have, that's what that equal to helps us with. If we didn't have the equal to, 2 isn't greater than 2, it wouldn't work. So that equal to piece helped us out there. Gave us that solid line. Where if I have this symbol, this is a dashed line. Okay? So when you have the less than or equal to symbol, you've got to use a dash, or excuse me, a less than or greater than symbol. You have to use a dashed line. If you have a greater than or equal to, or excuse me, a less than or equal to and a greater than or equal to, then it's a solid line. This means the points on this line are solutions. This one means the points on this line are not solutions. Okay, so make yourself a note. And on number 3, I want you guys to figure out where to shade for number 3. All right, what do we think? Shade above or below? Below. So you guys tested 0, 0 and it worked? 0 is less than or equal to, this part's 0 plus 1, less than or equal to 1. That's true, so we shade down here. All right. What if I would have tested this point? Would it work? Tell your neighbor why it would or would not work on number 3. Why would the ordered pair 0, 1 not work, or why would it work?
Because it's on the line, so it can't be equal to.
Okay, how many say, yep, it works? Nope, it doesn't work? Why doesn't it work? Caden, go for it.
Because when we have like open circle and closed circle, the open circle, the answer can't be that number. Like it was x and then it is like a non-circle area, then it would be the answer. Because that's the
Good. You'd have to have the equal to piece, right, to make it a solid line. So it's on a dashed line. It won't work. And here I've shown it. If we had the solid line, if we had the equal to piece, it would work. But this says 1 is less than 1, and we know that's not true. If we put that solid line, which would mean we have the equal to piece, that means 1 is less than or equal to 1, and then it would work. But since this piece isn't here, since that equal to piece isn't there, it doesn't work out for us. All right, good. Any questions? Okay, what I want you to do right now, I want you to go back to this page, page 159. On page 159, I want you to summarize your own words some of these definitions. Now, the kind of weird one's half planes, and really half plane is just separating your coordinate plane into a shaded and a non-shaded region. This is the half plane. In fact, I haven't seen that term used tons, but between the shaded and non-shaded, that's a half plane. Okay? But maybe summarize those and then read over how to graph. Maybe even put your favorite point in step 2 to test. Okay? All right, give you guys a few minutes to do that there. Okay, any questions? Hey, what point did you guys put here to test? 0, 0? Will 0, 0 always work to test that one? Huh? Almost always. So, Jake, which number on this sheet would it not work on?
It wouldn't work on number 6.
Okay, good. It wouldn't work on number 6. Why wouldn't it work on number 6? Someone else. Marie? Yeah, it already goes through 0, 0. Okay, so you got to test another point, right? Now, if I'm not testing 0, 0, I'm probably testing a point that starts with 0, maybe 0, 1, or 0, 2, or 0, 3, something with a 0 for x, because that just makes this part disappear. All right, so if I pick, say, 0, 1, okay, I test that point, I put 0 in for x, that part's gone now, and the 1 goes here. We say, well, is 1 greater than 0? The answer is yep. So we shade over that point. Okay? So it almost always works to use 0, 0 unless it's going through that point. Okay. Any questions? All right. So your assignment today, if you want to finish and find out how might a psychiatrist describe a paper plate, you can. I know that some of you have been waiting all weekend to figure that out. So those of you who haven't, that's okay. I won't hold it against you. Okay, your assignment today, if you look at page 150 or 160 of your student journal. Okay. Page 160, we're going to go ahead and start up on that. All right, so on page 160, you're going to complete this up here. Tell whether the ordered pair is a solution. And then graph the inequality. Now, please note on number 7, 8, 9, 10, 11, 12, these are a bit different, right? They only have one variable. So the graph of y equals 4, I know that says y is less than 4, but the graph of y equals 4, everyone show me with your arm, which way does that go? A y equals graph. We've done a lot of this year. And the y-axis goes like this. It goes straight up and down like my pencil here. However, y equals goes like that. It crosses only the y-axis. Where does it cross? Yeah, it crosses at 4. Y equals 4 is this line right here. Okay? Notice it's dashed. Can you still test 0, 0? Yeah, it's just you put 0 in here. 0 is less than 4. Is that true? Yeah, it's true. Shade down here. It's okay to still test that. It just we wouldn't bother with the x point. Okay, so we still test this point. Okay, everyone show me with your arm on number 10. Which way does x equals negative 1 go? Straight up and down or sideways? Go like this or like this? Crosses which axis? Crosses x. Where does it cross x? At negative 1. Solid line here. Can you still test 0, 0? Yep, still test 0, 0. You put it in, try it out. Okay, and I'll let you finish that. So you're going to complete page 60 and 61. Okay? Now if you want, these work really well using standard form. Those of you who remember how to use standard form, if you take a look at number 16, tell your neighbor how you could use standard form to graph that, rather than changing it to y equals mx plus b. Quick review of standard form. Go for it. Talk about it. How do I use standard form? Anyone? TT? Yeah, you find the y and x intercepts. So how do I find the y intercept? Yeah, when x is 0, you put 0 in for x. What's the y-intercept on this one? What's left? Negative 3. Y-intercept's negative 3. How do I find the x-intercept? Come on, man. X-intercept is when y. Yeah, when y is 0. So what's the x-intercept? Yeah, negative 3. Put it in right there. All right, we have 2 points. We can draw our line, and then we test those points. If you want, you could put it in slope-intercept form. You could get y by itself. Okay, there we go. All right, you have the rest of the class, and I'll have the home or the answers up. You can check them and make sure you're asking for help, please. Okay.